Worlds beyond our own. The universe is vast and filled with wonders that stretch far beyond our imagination. From the smallest particles to the largest galaxies, every corner of the cosmos holds secrets waiting to be discovered. Stepping stones to the cosmos. Our journey to understand the universe begins with the tools we use to observe it. Telescopes, both on Earth and in space, have opened our eyes to the wonders of the night sky. They allow us to peer into the depths of space and time, revealing the beauty and complexity of the cosmos. Our sun is a star. It is the closest star to us and the source of all life on Earth. The sun's energy drives our climate and weather, and its light sustains the plants that provide us with food and oxygen. But the sun is just one of billions of stars in our galaxy. There are billions of stars in our galaxy, the Milky Way. Each of these stars is a potential sun, with its own system of planets and moons. The Milky Way is a vast and complex structure with spiral arms that stretch out across tens of thousands of light-years. It is home to a diverse array of stars, from young, hot blue stars to old, cool red giants. And there are billions of galaxies in the universe. Each galaxy contains billions of stars, and each star may have its own system of planets. The sheer scale of the universe is mind-boggling, with distances measured in light-years and timescales that span billions of years. The more we learn about the universe, the more we realize how much there is still to discover. Could our sun be the only star with planets? It's unlikely. In fact, we now know that planets are common throughout the galaxy. These planets, known as exoplanets, come in a wide variety of sizes and compositions. Some are small and rocky, like Earth, while others are gas giants, like Jupiter. We call these planets around other stars exoplanets. The discovery of exoplanets has revolutionized our understanding of the universe and our place in it. Each new exoplanet discovery brings us one step closer to answering the age-old question, are we alone in the universe? Exoplanets come in all sizes. Some are small and rocky like Earth, while others are gas giants like Jupiter. There are even exoplanets that are larger than Jupiter, known as super-Jupiters. The diversity of exoplanets is truly astounding, and each new discovery adds to our understanding of the universe. Some are small and rocky like Earth. These rocky exoplanets are of particular interest to scientists because they may have the right conditions to support life. By studying these planets, we can learn more about the potential for life elsewhere in the universe. Others are gas giants like Jupiter. Some are even bigger. These massive planets have thick atmospheres made up of hydrogen and helium, and they often have multiple moons orbiting them. The study of gas giants can provide valuable insights into the formation and evolution of planetary systems. They orbit their stars in different ways. Some exoplanets have orbits that are very similar to those of the planets in our solar system, while others have highly elliptical orbits that take them far from their parent star. The study of exoplanetary orbits can help us understand the dynamics of planetary systems and the processes that shape them. Studying exoplanets helps us understand our place in the universe. By learning about the diversity of planetary systems, we can gain insights into the processes that led to the formation of our own solar system. The study of exoplanets also has the potential to answer some of the biggest questions in science, such as the origins of life, and the potential for habitable worlds beyond our own. Are there other Earths out there? The search for Earth-like exoplanets is one of the most exciting areas of research in astronomy. These planets, which are located in the habitable zone of their parent star, have the potential to support liquid water and possibly life. The discovery of an Earth-like exoplanet would be a major milestone in our quest to understand the universe and our place in it. Could there be life on other planets? These are big questions. The search for life beyond Earth is one of the most profound scientific endeavors of our time. By studying exoplanets and their potential for habitability, we can begin to answer these questions and gain a deeper understanding of the universe and our place in it. Cosmic detective work unmasking hidden worlds. The universe is vast and filled with countless mysteries waiting to be uncovered. Among these mysteries are exoplanets, planets that orbit stars outside our solar system. These hidden worlds hold the potential to answer some of our most profound questions about the cosmos and our place within it. Finding exoplanets is hard work. It requires patience, precision, and a deep understanding of the universe. Astronomers and scientists dedicate their lives to this pursuit using advanced technology and innovative methods to detect these distant worlds. The process is akin to searching for a needle in a cosmic haystack. They are very far away and very dim compared to their stars. The light from these exoplanets is often drowned out by the brilliance of the stars they orbit. This makes the task of finding them incredibly challenging. However, with perseverance and ingenuity, scientists have developed techniques to overcome these obstacles. It's like trying to see a firefly next to a spotlight. Imagine standing in a brightly lit room and trying to spot a tiny firefly buzzing around. The glare from the lights makes it almost impossible to see the faint glow of the firefly. This analogy perfectly captures the difficulty of detecting exoplanets, but NASA has clever ways of finding these hidden worlds. Through years of research and development, NASA has equipped its scientists with the tools and knowledge needed to peer into the depths of space and uncover these elusive planets. Their efforts have led to groundbreaking discoveries and a deeper understanding of the universe. Scientists use special telescopes in space. These telescopes are designed to operate beyond the interference of Earth's atmosphere, providing a clearer and more detailed view of the cosmos. By positioning these telescopes in space, scientists can observe the universe in ways that are not possible from the ground. These telescopes can see the faintest changes in light from distant stars. They are equipped with highly sensitive instruments that can detect even the slightest variations in starlight. These changes can indicate the presence of an exoplanet passing in front of its host star, momentarily dimming its light. Even a tiny dip in a star's brightness could mean a planet is passing by. This method, known as the transit method, has been one of the most successful techniques for discovering exoplanets. By carefully monitoring the brightness of stars over time, scientists can identify the telltale signs of a planet's transit. These telescopes are like powerful cosmic detectives. They gather clues from the light of distant stars, piecing together the evidence needed to confirm the existence of exoplanets. Each discovery adds a new piece to the puzzle of our universe, revealing the diversity and complexity of planetary systems beyond our own. They help us uncover the secrets of planets light years away. Through their tireless efforts, scientists are expanding our knowledge of the cosmos and bringing us closer to answering the age-old question, are we alone in the universe? The search for exoplanets is not just about finding new worlds, it's about understanding our place in the grand tapestry of existence. The Kepler Space Telescope, a legacy of discovery. The Kepler Space Telescope was a rock star in the world of astronomy. Launched in 2009, Kepler stared at one patch of sky for years. It watched for the telltale signs of planets crossing in front of their stars. Kepler found thousands of exoplanet candidates. Its discoveries revolutionized our understanding of planets around other stars. Thanks to Kepler, we now know that planets are common in the Milky Way galaxy. Transiting Exoplanet Survey Satellite, TESS, expanding the search. After Kepler's mission ended, TESS took up the torch. TESS is like Kepler's successor. Launched in 2018, TESS is scanning almost the entire sky. TESS is looking for planets around nearby bright stars. These are the best targets for follow-up observations. With TESS, we are closer than ever to finding another Earth-like planet. Section 5. The Transit Method, catching a planet's shadow. One way to find exoplanets is to look for their shadows. This method is particularly effective because it allows astronomers to detect planets that are otherwise invisible due to the brightness of their host stars. By observing the slight dimming of a star's light, scientists can infer the presence of a planet. This is called the transit method. It involves monitoring the light from a star over a period of time to detect periodic dips in brightness. These dips occur when a planet passes or transits in front of the star from our point of view on Earth. Imagine a tiny flea passing in front of a huge lamp. Even though the flea is minuscule compared to the lamp, it still blocks a small portion of the light, creating a shadow. This analogy helps us understand how a planet, despite being much smaller than its star, can still cause a detectable dip in the star's brightness. The flea would block a tiny bit of light from the lamp. Similarly, when a planet transits its star, it blocks a fraction of the star's light. This reduction in light is what astronomers look for when using the transit method to discover new exoplanets. When a planet passes between its star and Earth, it blocks a tiny bit of the star's light. This event is known as a transit. The amount of light blocked depends on the size of the planet relative to the star. Larger planets block more light, creating a more noticeable dip in brightness. This causes a slight dip in the star's brightness. By carefully measuring these dips, astronomers can determine the size of the planet and its orbital period. The light curve, which is a graph of the star's brightness over time, reveals these details. By measuring these dips, astronomers can learn about the planet's size and orbit. The depth of the dip indicates the planet's size, while the timing of the dips reveals the length of the planet's orbit around its star. This information is crucial for understanding the planet's characteristics and its potential habitability. Section 6. The Wobble of Stars. Unveiling planets through gravity. Planets don't just orbit stars, they also make stars wobble. This is because of gravity. Imagine two people holding hands and spinning around. They both move a little bit, even though one person is bigger. A star wobbles slightly because of the gravitational pull of its planets. Astronomers can detect this wobble by looking for tiny shifts in the star's light. This method, called the radial velocity method, can tell us about the planet's mass. Section 7. Remarkable discoveries, a universe of possibilities. We've found some pretty amazing exoplanets. Some are hot Jupiters, gas giants orbiting very close to their stars. Others are super-Earths, rocky planets bigger than Earth. We've even found planets in the habitable zone. This is the region around a star where temperatures are just right for liquid water. Water is essential for life as we know it. Could these planets harbor life? Section 8. The Quest for Life. Are we alone? Finding life beyond Earth is one of the biggest questions in science. Studying exoplanets brings us closer to answering this question. We're looking for planets with the right conditions for life. We're looking for signs of water, oxygen, and other ingredients for life. Future telescopes will be even more powerful. They'll be able to study the atmospheres of exoplanets for clues about life. Section 9. A Future of Exploration, New Horizons in Exoplanet Science. The study of exoplanets is a young and exciting field. Every new discovery brings us closer to understanding our place in the cosmos. New telescopes and technologies are on the horizon. These advancements will allow us to study exoplanets in greater detail than ever before. The future of exoplanet science is bright. We are on the verge of incredible new discoveries that will continue to amaze us.